This video will explain the type of transformer or type of substations used in medium type of industries. Actually, there are two classifications. First one is outdoor substation, second one indoor substation. So outdoor substation can be also classified into two: pole mounted substation and floor mounted substation. And pole mounted means the transformer is placed on a pole. Okay, floor mounted means the transformer is placed on the floor. So that is the difference between pole mounted and floor mounted substation, and the layout of these two, pole and floor mounted, are same. Okay, so in this video we discuss the outdoor substation. So this is the layout of outdoor substation. Okay, so mainly the incoming supply is coming from the service provider or electricity board. So this is the incoming supply, that is 11 kV. And the first thing is we install a lightning arrestor. Okay, 11 kV lightning arrestor. So that is the first part, first element in the primary side of the transformer, lightning arrestor. So the main function of this lightning arrestor is to protect the transformer and circuit against the over voltage due to the lightning. Okay, lightning. So this over voltage is arrested by the lightning arrestor and it discharged to the ground. Okay, so that's why we connect the lightning one end of the terminal which connects to the earth. And the second element is gang operating switch or GO switch, 11 kV gang operating switch or GO switch, or also we can name it Airbrakes switch, Airbrakes switch. So the function of Airbrakes switch is to we can open or close the circuit. Okay, we can interrupt the current and we can make the circuit to allow the current flow. So that is a switch, gang operating switch. The next element is HG fuse or horn gap fuse. Horn gap, HG or horn gap, 11 kV HG fuse. So the main function of fuse, okay, HG fuse is same like a simple fuse because when the overcurrent flows through the fuse element, the fuse element melt and it isolate the faulty system from the remaining system or remaining part. So that is the function of HG fuse or horn gap fuse, or also the another name is DO fuse. Okay, DO fuse, dropout fuse. Okay, HG fuse is also known as dropout fuse. Then after the dropout fuse, we install a transformer. Normally we install a transformer of delta star connection, 11 kV bar, 415 volt transformer. And capacity of transformer is decided by the maximum demand of the industry. And from the secondary side, we take a cable, underground cable, or a cable that carries the secondary current. So normally we are using 3.5 core cable, 3.5 or 3.5 core cable, because it is a three-phase system. So that the first three wire, the 3.5 core means it consists of four number of wire. Okay, out of these four wire, three wires are used for phase connection. So one for R, one for Y, one for B. So three are used for phase connection, and fourth one is used for neutral connection. So why we name 3.5 core means the fourth one that is used for neutral wire, the size of the fourth one is the half of the size of the first three wire. Okay, so that's why we name it 3.5 core. So this 3.5 core is connected to a main LT switch or MSB. This is the MSB or main LT switchboard. Okay, so from this LT switchboard we connect to the different loads. So that is the general layout of a outdoor substation. And now you can see a H-pole mounted substation. So this is the a drawing of H-pole mounted substation. So it consists of two pole. Okay, two pole. So this is the first pole. So this is the second pole. And a transformer is placed above a cross arm that connects between two pole. So it looks like a H-shaped structure. So that's why it is known as H-pole structure transformer. So transformer is erected or installed on the cross arm that connects two pole. Okay, and here also the first element, the incoming supply is coming from the electricity board in the overhead line and it connects to Airbrakes switch. So this is the Airbrakes switch. So the function of Airbrakes switch is to make or break the circuit. So we can open or we can close the circuit as we desire. So this air brake switch is connected to an operating handle. So you can see operating handle which connects the air brake switch. So this is the operating handle. So this is the operating handle. So by using this operating handle, we can close or open the air brake switch and we interrupt the current. And the second element, after the air brake switch, we connected to lightning arrestor. So function of lightning arrestor is to protect the circuit or equipment due to the over voltage due to the lightning. Then after lightning arrestor, we connect a HG fuse or dropout fuse. So this is the HG fuse or dropout fuse. Okay, so the main function is to protect the transformer, because when the short circuit occurs, the large amount of current is flows through the fuse, HG fuse. So it detects the large current of amount of current, and it isolate the circuit. Okay, so it melt down the fusing element, so that we can disconnect the transformer from the faulty system. So that is the function of HG fuse. So after HG fuse, we connect the primary side of the transformer. So this is the bushing of primary side. So we connect the primary side of the transformer. Okay. Then from the secondary side, so the lower part is the secondary side. From the secondary side, we tap the secondary voltage, and we directly connect it to a LT, low tension distribution box. So this is the distribution box. Okay, so inside the distribution box, the lot of fuses are arranged for protecting the secondary side of the line. So from the distribution board, we take the another lines, overhead lines. So this is the overhead lines, and we supply the secondary side or secondary voltage through this line, and we connect to different loads. Okay, so that's all the these are the main equipment in a H-pole mounted structure. And the defining for a defining consideration, the distance or these numerical value are very important. So you can see that the 750 centimeters, all are in centimeter. 750 centimeter is the height of the pole from the ground level, 750. So that is the height of the pole. Then you can see that the distance between the air brake switch and lightning arrestor, that is 80 centimeter. That means the lightning arrestor are placed a distance of 750 minus 80 from the ground level. Okay, so the clearance between the HG fuse or a line is in HT side is 76 centimeter. Okay, and the transformer is installed. Okay, this is the transformer installed position. So the transformer is installed 244 centimeter from the ground level, and the primary bushing of the transformer should be located at the position of 346 centimeter from the ground level. Okay, and the positioning of HG fuse or dropout fuse is 490 centimeter from the ground level. Then LT line, secondary transmission line, distribution line, that positioned 549 centimeter from the ground level. And this is the operating handle, and operating handle is located 125 centimeter or 1.25 meter from the ground level. Okay, so these are the main numerical design parameter in a H-pole mounted structure transformer. So the air brake switch, this is the air brake switch that used in the top of the H-pole mounted structure transformer. So this is the diagram or a drawing of a air brake switch. So you can see a air brake switch. Okay, so this is the blades. Okay, we can open these blades by using operating handle. Once we open the this blade means we can isolate the circuit. So this is the blades which connect between the two sides of the air breaker switch. Okay, so now in this figure it is the closed one. We can open this blade by using the operating handle, and we disconnect the circuit from the system. Then horn gap fuse. This is the horn gap fuse. You can see a horn gap fuse diagram. So here there is a fusing element is there. Okay, so when a large current which flows through the horn gap means the fuse wire melt and it disconnect the circuit. Then some installation consideration of a substation, outdoor substation. The minimum clearance between the supplier and consumer shall be 3 meter. So this is very important figure, 3 meter. Okay, the H-pole mounted structure and consumer building should be located a distance of 3 meter. Okay, then face to face clearance 950 mm should be 950 mm, and face to earth clearance 610 mm. Then minimum safety clearance of 2.6 meter between the bare conductor and live parts. Then lightning arrestor is installed between air brake switch and dropout switch. Okay, actually we can see the figure, H-pole mounted structure. So in this, the lightning arrestor is installed between the air brake switch and HG fuse. Okay, that's all. Now AB operating handle, so that located 1 meter or 1.25 meter from the ground level. So these are the main design consideration of outdoor substation. Thank you.